All right, in this third example, part C of example 3, we are going to, again, use our calculator to find each of these calculations, but if you notice, we have data that is in intervals. So the weight of cats, 50 cats are recorded in the table below. It is a frequency table, but again, the data values are in intervals. And so the issue is that we don't have the raw data. So we don't know the exact values of each of those 50 cats. We just know that five cats weigh between 2 and 3 pounds. And the way that these intervals are set up is each interval is including the lower boundary, but excluding the upper boundary. So for example, these 5 cats could have weighed 2 pounds or anything up to, but not including 3. So anything right up until 3 pounds, but not including 3 pounds. If they weigh 3 pounds, they are in the next interval. So the issue here is that we don't know if these 5 cats weighed all 2 pounds or if they were dispersed throughout this interval evenly. So that's part of what we have to consider when we use our calculator, in this case, really to estimate these values. So we can still make estimations of these values that we've done before, but that's exactly what it is. It's an estimation. So we still go about this in the same way, except part of what we have to do now before we enter our data is we have to find the midpoints. Right. So for this data set, right here, instead of using these intervals for my data list, so I'm going to use this as my data list, or L1. My frequency list is still going to be L2, but I have to find the midpoints of these intervals. And to find the midpoints, you just add up the lower and upper boundary and divide by 2, right? You're just finding the middle. So 2 plus 3 is 5, divided by 2 is 2.5. 3 plus 4 is 7. 7 divided by 2 is 3.5. And if you notice a pattern here, it's going to be 4.5, 5.5, 6.5, and 7.5. So what I'm going to do with those values are I'm going to type those into my calculator into L1. So I'm going to go to Stat, Edit. Again, I have data in from the previous example. So I'm going to scroll up to the top of the list, hit Clear, Enter. Same thing for the next one, Clear, Enter, and now I'm all set. So now typing in the data, again, be careful. Make sure you type in carefully, 2.5, 3.5, 4.5, nope, C. Made a mistake, 4.5, 7.5, 3.5, and 7.5. Okay, now you need to type in the frequencies, right? So now the frequencies to correspond, 5, 19, 17, 5, 3, 1. Again, we're using the midpoint because, again, that's just our best guess as to what the average value is in these intervals. So we're using the midpoints as our data values from each interval, and that will be used to calculate with the frequency each of these values then. So after you find the midpoints, and then you enter the midpoints and the frequencies, the process then is the same. Stat, scroll over to calculate, option 1, one variable statistics. L1 is still my data list. In this case, represents the midpoints. Frequency is L2, still the frequency list. Scroll down to calculate, enter, and there's my list of information. So again, mode, right? So the mode in this case is the modal class. That's one thing that's a little different here with my interval data. When we talk about the mode, I actually want to type in the modal class. So it's the class that occurred the most often. So 3, which is less than or equal to W, which is less than 4, is my modal class. Okay. It's not the midpoint, right? So the modal class is 3 to 4. The midpoint that corresponds is 3.5, but it's the interval that I list for the mode. All right, again, we've talked about the mode. It's just the most frequent data value. In this case, not data value, but interval. And the mean, most of the rest of these come from, again, your calculator. The mean in this case is 4.2. That is an estimate, right? So remember, we use the midpoints of these intervals. That means these are estimates. The mean is an estimate, estimated mean. Standard deviation in this case is 1.1. Minimum is 2.5. Q1 is 3.5. Median, 1.5. Remember, the median is simply half of the data falls below 4.5 and half above. This is, again, an estimate, right? So we don't know exactly what the median is, but the estimated median is 4.5. Upper quartile is 4.5 as well. Maximum is 7.5. Again, range is still the maximum minus the minimum. So 7.5 minus 2.5 is 5. The interquartile range, 4.5 minus 3.5 is 1. So those are fairly compact, fairly small for the interquartile range at least. The range, if you're comparing it to the rest, right? So the rest of our data, the range is fairly large, but the interquartile range is fairly small. So the middle 50% of my data falls within 1 kilogram, right? So 1 interval, really. Let's go back here and interpret a little bit here. Interpret the mean. Again, this is an estimated. Since we used the midpoint for each interval. Again, it's an estimate, but it gives us an idea of the general average. So again, 4.2 kilograms, the average weight of the cat, average data value. Deviation is 1.1. Again, that's not too large. So our data is fairly compact. Data is fairly close to the mean, which means compact. Another way to say that. The dispersion, right? It's a very small dispersion of data. Again, you can kind of see that with your data set. Majority of the data falls between 2 intervals. And so the standard deviation there, most of your data is clumped close to the mean. Right? If you notice the mean is 4.2, that would be within this interval, and most of that data falls close to that interval. Any of those values that would distort the mean, I would say not really. Again, the intervals are all connected. It's not like we're jumping from 2 to 3, 3 to 4, 4 to 5, all of a sudden to 20 to 30, 30. So all of the data is fairly connected and similar. So no, not really in this case. There's no outliers, we would say. And other than that, again, just recognizing when you have data given to you in a certain way. So in this case, in a frequency table, but also in intervals, really we can only make estimations here based on the information we're given. If we had all 50 data values written or given to us, we could go to our calculator, stat, edit, and type in all 50 values and run a 1 variable stat calculation and get the exact values. But with the data as is, there's only so much we can do. Okay? So these are the things that you need to feel comfortable with using your calculator to do with 1 variable statistics. These 3 examples are things that you have to be able to do. Okay, so recognizing what type of data you're given, when you use your calculator, how to plug it in, and then what values your calculator will give to you.